There are actually 5 additional examples that I'm going to work for Section 4, so you have plenty to go on here to help you with. The first example says, last year the revenue for medical equipment companies had a mean of $50 billion, with a standard deviation of $11 million. Find the percentage of companies with revenue greater than $30 million. Assume the distribution is normal. So in this case, it doesn't say anything about the empirical rule. The empirical rule might work, and so we can go over to this graph and see if it does. We've got 50 was our mean, and 11 is the standard deviation, so that would take us up to 61, 72, and 83, and down to 39, 28, and 17. We want greater than $30 million, so that's about right here. It's not quite 2 standard deviations below the mean. And so we're not going to be able to use our empirical rule because it's not exactly 2 standard deviations below the mean. So what we use is the Z-score. So from our notes, our Z-score is the data value minus the mean over the standard deviation. Our data value here is 30, the mean is 50, and the standard deviation is 11. Gives us negative 1.818. So we are 1.818 standard deviations below the mean. To find the percentage that's greater than negative 0.818 standard deviations below the mean, the easiest way to do that is to use Excel. Now, I'm not going to go over to Excel and do this right now, but all you have to do is enter this into Excel, equals, and then for greater than, we have to do 1 minus. If you don't do 1 minus, it's going to find less than. So naturally, when we use this formula, it will naturally find less than. We have to do 1 minus to get greater. So 1 minus norm.s.dist, and then we plug in our z-score, negative 1.818, comma, the word true. And that tells us, as a decimal, the area to the right of that z-score is 0.9656. So as a percent, it would be 96.56% of the companies have a revenue greater than $30 million. Example 2 says, what percentage of the area under the normal curve is to the left of negative 1.35 and to the right of negative 0.24. So negative 1.35 would be about here, that many standard deviations below the mean, and we want the area to the left. Negative 0.24 would be maybe right here, and we want the area from there to the right. So what we're going to do is we've already got the z-score, so we don't have to use that, but we're going to use Excel, those little formulas that we put into Excel to find each of these. So first we need to the left of negative 1.35. So to the left is just equals norm.s.dist negative 1.35 comma true. And that gives us 0.088508. Then we want to the right of negative 0.24. And remember, to the right, we have to put equals 1 minus, and then our norm dot s dot dist negative 0.24 comma true, and we get 0.594835. So we want the percentage to the left and to the right. So we're going to add them. So our total would be 0.088508 plus 0.594835. 0.68343. So changing that to a percent, the two decimal places would be 68.33% of the data is to the left of the first Z-score and to the right of the second. Example 3 says a water bottling facility has a mean bottling rate of 32.4 thousand bottles per hour with a standard deviation, I'm going to underline here, with a standard deviation of 1.84 thousand bottles. A nearby cola bottling facility has a mean bottling rate of 27.5 thousand bottles per hour with a standard deviation of 1.46 thousand bottles. On Wednesday afternoon, from noon to 1 p.m., the water bottling facility bottles 34.3 thousand bottles of water, and the cola bottling facility bottled 29,000 bottles of cola. Which facility increased their efficiency more during that hour? So with different means and different standard deviations, it's impossible to just look at this and determine which one was more efficient during that hour. The way we do it is to look at the Z-scores. And if we can see the Z-scores to see which one has a standard deviation less from the mean, then that would tell us they had better efficiency. So the first one, the water bottling facility, the mean was, a data point is 34.3 minus a mean over the standard deviation, and we get a Z-score of 1.0326, which we'll just round to 1.03. Then the cola bottling facility, their data point that we're looking at is 29, minus their mean of 27.5 divided by the standard deviation of 1.46, and we get 1.0274, which I'm going to round to 1.03. So what does this tell us? Well, the Z-scores are the same. So they both actually increased their efficiency by the same amount. I don't think there's two N's in there. Okay? If we hadn't gotten negative Z-scores, that means their efficiency had decreased, by the way. Example 4 says, use the formula for Z-score to determine the missing value. So our formula for Z-score, this is for population because we have mu and sigma, would be our data point minus the mean, which in this case is mu, divided by the standard deviation, sigma. So this time we're looking for mu. We have z, we have x, we're looking for the mean. So we're just solving this equation. Multiply both sides by 7.36. We have 4.7104 equals negative 23.40 minus mu. And then we're trying to get mu by itself, so add 23.40 to both sides. 28.1104 is negative mu, and we got to get rid of that negative. So we can either multiply both sides by -1 or divide both sides by -1. Either way will work, and mu ends up being negative 28.11 for the mean. And our last example says, last year the revenue for financial service companies had a mean of $70 million with a standard deviation of 18 million. Find the percentage of companies with revenue between $50 million and $90 million. Assume that the distribution is normal. So we could draw a curve here. This time I'm not going to worry about it. We want between 50 million and 90 million. Okay? So we want this amount in here. So what we can do is we can find the percent to the left, or the area to the left of the 50, and find the area to the left of 90, and subtract them to get the area in between. So, to find the area to the left of 50, we'll find the z-score, 50 minus our mean, divided by the standard deviation, is negative 1.11. And then we plug into we want to the left, so it's just equals norm.s.dist, negative 1.11, comma true, gives us 0.1335. Then we find the z-score for the data value of 90. That's positive 1.11 equals norm.s.dist, positive 1.11, comma true, 0.8665. So to find our area between, we'll take 0.8665 and subtract 0.1335. We get 0.7330, or as a percentage, 73.3%. So 73.3% of these companies had a revenue between $50 million and $90 million. And that's finally it for this section's extra example.